students, how are you? So I am going to continue with the relative motion. How the relative velocity is being applied to solve the complicated problems. One problem I have taken over here, two cars, A and B. A is moving towards B with initial velocity of 29 meters per second. That is a constant velocity. And B is moving with acceleration of 2 meters per second square in that direction, whose initial velocity is 0. Initially, the distance between these two cars is 300 meters, and we have to find whether A will be able to catch B. If it catches, then how much time will it take? If not, then what will be the shortest distance between A and B? Right? That we have to find. So that can be solved in various methods. So I will solve it with the relative velocity concept. So solution. See, it is given, this is the car A, it is moving with velocity 29 meters per second. This is the car B, its initial velocity is 0 and acceleration is 2 meters per second square. The distance between these two is given to be 300 meters. Now, we will solve it by relative velocity concept. So, we will find the relative velocity of A with respect to B. I will make B at rest, because in relative velocity I have already told you. Suppose velocity of A with respect to B is to be found out, then B will have to be brought to rest. So if this is brought to rest, in that case, what will be the velocity and acceleration of A? That we will find out, and the whole equations of motion we will use that velocity and that acceleration. So we will see that velocity of A with respect to B is equal to what? That is UA minus UB. And what is UA? That is 29 meters per second minus UB is 0, that is 29 meters per second. This is the velocity of A with respect to B. Similarly, we will find the acceleration also. So acceleration of A with respect to B is acceleration of A minus acceleration of B. Acceleration of A is 0 and acceleration in the same direction. We have taken this direction as positive and this direction as negative. So 0 minus 2, that is minus 2 meters per second square. So velocity is known, acceleration is known. With these two, relative velocity and acceleration, we have considered B as at rest. So, and the distance between them is 300 meters. Now we will use some formula so that we will find whether this will catch B or not. So we will use the formula S is equal to UAB into T plus half AAB into T square. S is equal to UT plus half AT square, but here I have taken relative velocity, relative initial velocity and the relative acceleration, and S is known. So with this we will try to find the T, and T means by that time A will catch B, isn't it? So therefore S is 300 and UAB is 29, T plus half A is minus 2 T square. Further simplification, 2 will go, that is minus 1. Therefore this is 300 is equal to 29T minus T square. We will take everything on left hand side, that is T square minus 29T plus 300 is equal to 0. So what do we see? That this equation is the quadratic in T. So whether we will get the real value of t in the solution or not, that we'll have to confirm. So first we will find the conditions. If the conditions of getting real values of solution in a quadratic equation, if that condition is getting satisfied, it means we will get the real values, otherwise no. So what is the condition for a quadratic equation to have real solutions? So in general, if you will consider, that is ax square plus bx plus c is equal to 0. Suppose this is the general quadratic equation, the standard quadratic equation. Then what is the condition under which this equation will give real solution? The solution will be a real value. So condition is, the condition for solution to be real values, that is b square minus 4ac should be greater or equal to 0. It is very important condition that you must know. So this is equation number 1, and suppose this is equation number 2. So this equation will give real values of t or not, because it is also quadratic. Highest power of this equation, that is variable power on highest power on variable t is 2, that is why it is quadratic in t. So compare these two, ax square plus bx plus c and t square minus 29p plus 300. If you compare 1 and 2, so we will get a is equal to, that is coefficient of x square, means variable square, coefficient of t square, that is variable square, that is equal to 1. So a is 1, b is equal to minus 29 and c is equal to 300. So you'll see the condition, whether condition is getting satisfied or not. Therefore b square minus 4ac is equal to minus 29 square minus 4 into 1 into 300, right? So we'll find the value of this, minus 29. So we get over here 841 minus 1200. If you subtract this, you will get negative value, right? After solving this, we will, but it is 1200 is negative, 841 is positive, naturally we will get negative value. Means condition is not getting satisfied. It means we will not get the real value of t. Therefore, solution of equation 1 is not possible. That is, we will not get real solution. Since we are not getting real solution of this equation, it means there won't be that time during which A will catch B. It means A will never catch B. It means B will be coming closer, 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 and somewhere it will stop. With respect to B, it will stop. But since B is continuously moving, then afterwards B will feel that A is going back, because A will be having no acceleration, constant velocity, but it will be in acceleration. So after some time, first it will come closer to B, suppose it comes over here, and then since it is continuous accelerated, B will feel that A is going back. So the shortest distance between A and B is expected, right? So suppose it reaches at the point D over here. So we have to find this distance. This distance will be how much? Suppose it is x. So at what distance A will stop? And at that time, whatever the distance between B and D will be there, that is the shortest distance. So you will find at what distance A will stop. Here, the velocity of A with respect to B becomes 0. That situation will come, and this we have to find at what distance the velocity of A with respect to B will become 0. So, for shortest distance between A and B. V final velocity of A with respect to B should be 0. So AB is known, VAB is 0. We have to find the distance x is what, right? So we can use the equations of motion, third equation of motion, that is VAB square is equal to UAB square plus 2AS. Suppose in this case x. So this will be used. Final velocity is 0. Initial velocity is 29 square plus 2b, that is minus 2 into x. Therefore, 0 is equal to 29 square minus 4x. Therefore, x is equal to 29 square by 4, that is 841 by 4. And we can find the value of this, that is 212.5. Yes, 212.5 meters. This is this distance. So what is the closest distance? Therefore, the closest distance between A and B will be equal to 300 minus 212.5. That 87.5 meter. 87.5 meter. So it won't overtake B, but it will reach very close to B, and distance between A and B at that time will be 87.5 meter. It can be solved in different method also. That is the method of maxima minima, which you are not aware of, but still I will solve this problem with that method also. Right. Method 2. Here see, let's assume that after time t, right, it has moved some distance, and during the same time this also moves some distance. Suppose let the distance moved by A in time t is equal to suppose it is S1, right? So therefore S1 is equal to, initial velocity is 29 meters and there is no acceleration. Acceleration is 0 in this case. So 29t, right? A uniform velocity is there in time t. Velocity into time is the distance. Distance traveled is S1. And let the distance moved by B in time t is equal to S2, right? Then S2 is equal to what? Initial velocity is 0, 0 into t plus half into A is 2 into t square, right? That is equal to simply t square. That is distance moved by this in time t. So we will consider, this is, suppose here this is the position. This has moved by a distance of 29t, that is it is S1, and it has moved a distance, this one, it is S2, that is t square. So distance between these two we will find. B has moved here, right, that is S2, and A has moved up to this, that is 280, that is S1. So S1 is equal to this distance, right, that is 300 plus t square, right, 300 plus t square minus s1 will be the distance between A and B. Therefore, the distance between A and B after time t. See, I'll explain once again. B has moved a distance of S2, that is equal to t square we have found over here. S2 is equal to t square. It has reached up to this point. Suppose this position is P and this position is Q. And A has moved in time t the distance S1, that is 280. It is 2980 in fact, right? At 29t. S1. So what is this distance? This distance. This is how much? The 300 plus S2, that is 300 plus S2 minus S1. From here to here it is S2, here to here it is 300. 300 plus S2 means A to P and A to Q is S1. So this is the distance between final position Q at P. So that is equal to, let this distance be S, is equal to 300 plus S1, sorry, it is S2, S2 minus S1. Put the values. Therefore, S is equal to 300 plus S2 is, that is t square minus 29t. This is the equation we got. This is the distance, final positions after time t, the distance between A and B. Now this distance is to be maximum or minimum, depends on, that's why I told you I will be taking help of maxima minima concept of derivative, application of derivative, maxima minima. So to find the maximum distance, we will find ds by dt should be equal to 0 for maxima or minima. A distance between these two will be minimum or maximum, either of these two. ds by dt has to be 0. So here s is this, therefore ds upon dt is equal to how much? Differentiate this. This will become 0 plus 2t minus 29, that is equal to 0 according to this. Constant term, derivative is 0. Derivative of t square with respect to t is 2t minus 29t. Derivative of this is 29. So we will get, this implies t is equal to 29 by t. 29 by 2. We got this much time, 29 by 2 seconds. Its derivative is 0. Means either it will be maximum or minimum. We will find second derivative. Second derivative of this, that is d2s upon dt square, that is equal to 2. Since it is greater than 0, therefore at t is equal to 29 by 2, s will be minimum. This is the condition. If second derivative is greater than 0, very positive, then whatever value of s we will be getting, that will be minimum. So put the value, that is 29 by 2, and we will get the result. Therefore minimum s minimum, t is equal to 29 by 2, we have to put over here, that is 300 plus 29 by 2 whole square minus 29 into 29 by 2. Just to simplify and solve this, that is equal to 300 plus 29 by square by 2 we can take common. So 29 square by 2 if we take common, it is 1 upon 2 minus 1. Isn't it? Okay, it is 29 square upon 2 square, that is 4. So 29 square by 2 if you take common, so 1 by 2 will be left, and that is only 1 is left. So if you simplify this, that is 300 plus 29 square by 2 into minus half. Right? So that is equal to 300 plus 29 square by 4. This is minus over here. Simplify this and we will get the answer. That is 300 minus. This is 841 by 4. That is equal to 300 minus 212.5. That is 212.5. That is equal to 87.5 meter. The same answer we got with this also. So second method, process is different. That is our maxima, minima. You may not be aware, but you should know this. For the sake of that, I have solved this problem with the second method as well. This is another question pertaining to relative velocity. That is rain, and it is called rain and umbrella related problems also. And the velocity of person, velocity of rain with respect to person, what is the direction, what is the speed of rain. Different types of questions can be made related to rain and the person. So to a person moving eastward with a velocity of 4.8 kilometers per hour, rain appears to fall vertically downwards with a speed of 6.4 kilometers per hour. What is the actual speed and direction of rain? So I will draw the figure first. So direction wise, we see this east, west, this is north, and this is south. It is given that person is moving eastward is 4.8 kilometers. So okay, I will draw. This is person is moving with velocity of Vp. I'll say that is 4 kilometers per hour. It is moving eastward, and rain appears to fall vertically downward. Rain appears to fall vertically downward. This is V of rain with respect to person, that is 6.4 kilometers per hour. This is the velocity of the person. This is the velocity of rain which appears to the person, right? So we have to solve this problem. So concept we know that the velocity of, here also it is rain, velocity of rain with respect to ground minus velocity of person with respect to ground. That is the relative velocity of rain with respect to person. So what is needed? What is the actual speed and direction of rain? So we want this. So this can be written as velocity of rain with respect to ground we want. So transfer this on this side, the velocity of rain with respect to person plus velocity of person with respect to ground. Before reaching to the actual situation over here, mathematical presentation of relative velocity is seen. That velocity of rain with respect to person, velocity of rain with respect to ground, minus velocity of person with respect to ground. So since we need this, so this quantity will be transferred this side. So velocity of rain with respect to ground if you want. So we will say velocity of rain with respect to person plus velocity of person with respect to ground. So these are the vector quantities. So what is the vector addition of what we have to do? Vector addition of velocity of rain with respect to person plus velocity of person with respect to ground. Vector addition of these two we have to do. These things are known over here. Velocity of person, this is the vector, direction is known, and velocity of rain with respect to person, direction is known. So vector addition of these two will do means we will make a parallelogram, right? So this if you join, then this is the vector. Suppose the O, A, B, C. So OC vector plus OA vector is equal to OB vector. So what is the magnitude of OB and what is the direction? This is the actual direction of rain with respect to ground. So this is VRG, right? This is the actual direction of rain with respect to ground. So this is the geometrical presentation of this situation. So we will find the magnitude. See, it is 90 degree. So this is also 90 degree. We can find the value of this. It is VP since it's a parallelogram. This is also VP with respect to ground. In fact, with respect to ground only. That is equal to 4.8 kilometers per hour. So magnitude is given 4.8. Magnitude of this is 6.4. So OB can be found. OB, this magnitude of VRG can be found out. Therefore, OB square is equal to OC square plus CB square. And what is OC? Magnitude of VRP. That is magnitude of VRP, that is equal to 6.4 kilometers per hour. Magnitude of P with respect to ground, that is 4.8 kilometers per hour. And OC, OB we have to find. OC is 6.4, that is 6.4 square plus CB is 4.8 square. Therefore, OB is equal to under root of 6.4 square plus 4.8 square. We can calculate this and that will be the answer. What is OB? And this OB is magnitude of VRG. Means magnitude of actual direction of the rain with respect to ground. Actual velocity. This velocity appears to the person because he is moving. Actual velocity is this. Velocity of rain with respect to ground, and we will calculate and we will find the value of this. 6.4 square is equal to 40.96 plus the square of this is 23.04. Adding, we will get 64, means 8 kilometers per hour is the speed of rain actually with respect to ground. And which direction? We suppose this angle is theta. We have to find the theta with vertical. So we will find tan theta. Tan theta is equal to CB upon OC. That is CB is 4.8 upon AB is 6.4. So if you simplify this, 48 upon 64, that is equal to 3/4. So therefore, theta is equal to tan inverse 3/4. Means the actual direction of rain is making an angle of tan inverse 3/4 with the vertical. This is the solution. Concept of relative velocity is clear. If required, a few problems related to boat and river, aeroplane and air, similar problems are these. So those problems will also be taken. Concept should be understood. Once concept is clear, the number of problems can be solved. So I emphasize on the concepts. Understanding is more important. So I think you have understood this and you will be following it. So we will be meeting next time. Till then, all the best. Take care of you. Be healthy, be fit, be good in every aspect, and study consistently and maintain some timetable and prepare yourself better and better.